Hello everyone. This video is in continuation with our previous video Is the Matter Around Us Pure? If you haven't seen that video, do check that as well. And if you like our videos, then please give a thumbs up and subscribe to our channel. In our previous video, we discussed what are substances and types of mixture. Now we shall be discussing different types of solutions. A solution is a homogeneous mixture of two or more substances. For example, we have lemonade and soda. We studied homogeneous mixtures are those having uniform composition throughout. Usually, we think of solutions as liquid that contains either a solid, liquid, or a gas dissolved in it. We can also have solid solutions which are called alloys and gaseous solutions, air. In a solution, there is homogeneity at a particle level. Let us consider the example of a lemonade. Lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution, hence the homogeneity. Let us now discuss what are alloys. Alloys are mixtures of two or more metals or a metal and a non-metal, which cannot be separated into their components by physical methods. Alloys are called mixtures because they show properties of constituents and have variable composition. A very famously known example is of a brass, which is a mixture of 30% zinc and 70% copper. Moving forward, we know that solution comprises or can be categorized into two parts: solvent and the solute. Solute, which dissolves in the solvent, and solvent, which dissolves the solute. The component of the solution that dissolves the other component, usually the component present in larger amount, is called the solvent. For example, in a mixture of salt and water, solvent is the water. Similarly, the component of the solution that is dissolved in the solvent is called the solute. As in case of the mixture of salt and water, salt is the solute. Here we have an example of sugar in water, where sugar is the solute and water is the solvent. A solution of iodine in alcohol, which is called the tincture of iodine. In this case, solute is iodine and alcohol is the solvent. Aerated drinks like soda water are gas in liquid solutions. These contain carbon dioxide gas as solute and water as solvent. Moving on. Air is a homogeneous mixture of number of gases, 21% of which comprises of oxygen, 78% of which comprises of nitrogen, and the remaining is the small amount of other gases. Let us now move ahead to the properties of a solution. Solution is a homogeneous mixture. The particles are smaller than 1 nanometer, so cannot be seen by naked eyes. Considering the example of lemonade, when all the components of the lemonade are properly dissolved, we cannot see the particles of lemon or the particles of salt or sugar. Because of very small particle size, they do not scatter a beam of light passing through the solution. So path of light is not visible. In our previous lecture, we discussed an activity in which 4 groups A, B, C, D were taken. In that activity, group A and B formed a copper sulfate solution. Hence, they do not scatter a beam of light passing through the solution. So, the path of light is not visible. Also, when we performed the filtration process, we were not able to obtain the solute particles. The solute particles do not settle down when left undisturbed, that is, solution is stable. Therefore, from the previously discussed activity, the mixture of copper sulfate and water gives us a solution. Moving forward, Now we shall discuss what is a concentration of a solution. We observed different shades of solution in our previous activity. Remember the activity in which in group A we added 1 spatula of copper sulfate and group B we added 2 spatulas of copper sulfate, as a result of which we obtained variations in the color of our solutions. In our solution, the relative property of the solute and the solvent can be varied. Depending upon the amount of solute present, our solution can either be dilute, concentrated or saturated. The solutions are dilute when the amount of solvent is more. They are concentrated when the amount of solute is more. And we shall be discussing saturated and unsaturated solutions with the help of this activity. Let us now consider an activity. Take 50 ml of water in 2 beakers. Add salt to one and sugar or barium chloride in the second beaker with continuous stirring. Now, when no more solute can be dissolved, heat the contents of the beaker to raise the temperature by about 5 degrees Celsius and start adding the solute again. Now, we may wonder, is the amount of salt and sugar or barium chloride that can be dissolved in water at any given temperature the same? Well, at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. That is, at a given temperature, if any given solution has dissolved the maximum amount of solute according to its capacity, then the solution is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution, it is called a saturated solution. When the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. Let us now discuss what would happen if we were to take a saturated solution at a certain temperature and cool it slowly. From the above activity, we can infer that different substances in a given solvent have different solubilities at the same temperature. Solubilities depend upon a given solvent. The concentration of a solution is the amount of solute present in a given amount of a solution or the amount of solute dissolved in a given mass or volume of solvent. A solution is said to be highly concentrated if large amount of solute is present in the solvent. Here we have a formula. Concentration of solution is equal to amount of solute upon amount of solvent. The formula can also be written as amount of solute upon amount of solution. We have two ways of expressing the concentration. First is mass by mass percentage of solution. The formula is given as mass of solute upon mass of solution into 100. The second formula is mass of volume percentage of solution. The second formula is mass by volume percentage of solution. Mass of solute upon volume of solution into 100. With this, we come to an end of our today's video. Today we discussed what is a solution. We discussed what are alloys. We discussed various properties of the solutions. We discussed the concentration of solutions. Also, we discussed a few questions which were pending in our previous video. And also, we discussed certain formulas to calculate the concentration of the solution. If you like our videos, then please give a thumbs up and subscribe to our channel. Thank you.